So this video will be for the second trig lesson in your workbook, which is on page 209. So like I said, really quick lesson. We're going to do some calculator work in this lesson. And then we really get into trig and start solving for the triangles in lesson 3. So lesson 1 and lesson 2 are just giving you your prerequisite skills for lesson 3. So just to start this, to do a quick review of lesson 1, Lesson 1 was basically on SOHCAHTOA. Okay, so there's 3 trig ratios that you have to know, and those trig ratios are sine, cosine, and tangent. When we talk about the word ratio, what I'm talking about is fractions. And the fractions come from the sides of a triangle, right? So there's 3 sides of a triangle, and a trig ratio is going to be looking at a triangle and looking at 2 sides together. So the sine trig ratio is opposite over hypotenuse, the cos trig ratio is adjacent over hypotenuse, and the tan trig ratio is O over A. The other thing we did in lesson 1 is we labeled triangles. So for example, maybe we'll do this triangle here. So this triangle would be called ABO would be the name of this triangle. And the given angle is this one here, which is 58 degrees. So that's the triangle that gets a set of eyeballs. From there, side AB would be your opposite. Directly across from your 90-degree angle would be your hypotenuse. So OB would be your hypotenuse. And then by default, the last side, which is OA, would be your adjacent. Okay? What we're going to do now is what we had previously done. So if I said for this triangle here, you guys, what is, let's say, the sine trig ratio? You would have written the sine. Our angle goes in here, so that's where our angle goes. And sine is opposite over hypotenuse. Now I could actually write an angle in. So what is the angle that they want me to write in here? 58 degrees. So the sine of 58 degrees is equal to opposite over hypotenuse. So we always write our angle next to our trig ratio. So either sine, cosine, or tangent. Okay? So I'm just going to show you a few things on your calculator. So what it says is to 4 decimal places, they want us to calculate the tan of 35 and the tan of 58. Before we do this, let's make sure we're in the correct mode. So what was the test that I told you last class? What do you always type in for your test? Sine of what number? 90. So type in the sine of 90 and just close your bracket and hit enter. If 1 comes up, you are in the correct mode. So the sine of 90 degrees is 1. Okay, the tan of 35 degrees, we know that the ratio goes on the right-hand side, but a ratio is a fraction, right? So what is the answer to the fraction? How you would do that is you would just say the tan of 35 degrees, and you would hit enter. So the 2 sides, when you do tan is TOA, opposite over adjacent, this would be the ratio. So they want it to 4 decimal places, so 7002. The tan of 58 degrees, so tan again is TOA, and we don't know what the triangle is, but the ratio, if you divided the opposite over adjacent, would be, so tan of 58 degrees is 1.6003. Okay, I want you guys to take a minute, do A. Answer each of these to 4 decimal places. So some of them you're going to have to be careful with rounding. So when you're rounding, you look at the 4th number, like 1, 2, 3, 4, and then you look at the one to the right of it, is how you're going to decide if you keep that 3 or round it up. And then I'll ask 4 different people for these answers. Oh, and what did you get the sine of 35 degrees is? Yes. Ella, what did you get the cos of 35 degrees is? Yes. Okay, the sine of 58 degrees. Luke, what did you get for that one? Yes. And Sebastian, what did you get the cos of 58 degrees is? Yes. Okay, for class example B, it says it just wants to use you to use these numbers here with their trig ratios. So what it would be, let's just write SOHCAHTOA. So this first one, the sine of 35 degrees. 35 degrees would be the given angle in the triangle. And how they got this number here is on the triangle, they divided the O by the H, and they would have gotten 0.5736. They don't actually give us the sides of the triangle, but that's what you would get. If whatever the sides were, you would get that number there. And then the cos of 35 degrees. So for this one, cos of 35 degrees, cos is ka, which is A over H. So how they got that 0.8192 is on a triangle. They had two different sides, and the adjacent divided by the hypotenuse would have given you that number there. Okay, we won't write the sine of 58, but the sine of 58 degrees would be O over H, and the cos of 58 degrees would be A over H, right? It's just SOHCAHTOA. Flip your page. And we're actually going to skip everything on this page except for the very last class example, which is class example 4. So we don't do class example 2 or 3. And we're just going to do class example 4. So again, same thing. Nothing's different. Use your calculator to determine the value of each trig ratio to 4 decimal places. So the sine of 81, the tan of 14, and the cos of 44. So punch those in, get those answers. Okay, so Cade, what did you get for sine of 81 degrees? Yes. And Antonio, the tan of 14 degrees? Yes. Lucas S., the cos of 44 degrees? Yes. 0.7193. Okay, flip your page. Okay, so here's what I want you to write here in this space here. I want you guys to write the tan of 35 degrees is equal to, and I want you to give me your answer, what the ratio would be to 4 decimal places. And we're going to need it stored on our calculator, so clear your calculators and write down what the tan of 35 degrees is for me to 4 decimal places. So on your calculators, you'd say tan 35, and you'd hit enter. So tan is TOA, so the opposite side over the adjacent side would give us this answer here. So 0.7002. I call this, when you're figuring out the ratio, going forward on our calculator. Because what going forward means is we literally enter the tan button, we hit 35, and we hit enter. What I'm going to teach you now is this. So write down tan. We know that an angle always goes here, so I'm going to call this angle X is equal to, and then I'm going to give you the ratio. What I would be calculating now is this missing angle. Now we know what the missing angle is. You guys could just look up here. What is the missing angle going to be? What will this x value be? 35 degrees. Here's how we punch it in and get it on our calculator. So I always draw myself an arrow going backwards to tell me that this isn't going to be, I got to do something special on my calculator. So when I type in the tan of 35 degrees, that's going forward. I just type that in, hit enter, get my answer. When they give you a ratio and they tell you to calculate the angle, what you're going to write is you're going to write this. This is called an inverse function. So this guy here, we'll just write, this guy is a function. So the function is going forward. And this one is what we call an inverse function. We're going backwards to find the angle. Whenever I ask you to find an angle, you're going to do this. How you type it in or how you write it is to show me that you're going backwards is tan -1. Now, it's not actually a -1. How I would read this is the inverse tan. Then you open up a bracket and you type in the bracket, or you write the ratio goes in the bracket. So 0.7002. We're going to hit enter, and what will spit out is the angle. So how we type this in our calculator is as follows. Because I'm finding an angle, I'm going backwards. I'm doing an inverse function. So on my calculator, I'm going to hit the second function button, and then I'm going to hit tan. The -1 will appear. Then in the bracket, you write what the ratio is. So our ratio, we rounded, so 0.7002. You close that bracket and you hit enter. What will spit out is the angle. This is the angle. Yes, Piper. No, the bracket you don't actually need, but when we start adding and subtracting things together, you just get in the habit of closing that bracket, because I'll show you in one of the examples for the homework, you need to close the bracket or you'd get it wrong. Okay, so this would be rounded to the nearest degree would be 35 degrees. I was finding x, so I'm going to write 35 degrees here, and then I would say x is equal to 35 degrees. Okay, so I'm going to give you practice going backwards. So again, let's write this one. So they tell me the tan of angle x is 1.2. If it's written on the right-hand side, did they give me the angle or the ratio? If it's on the right-hand side, they gave me the ratio. So what they want is they want this angle. In order to get the angle, you have to write it as the inverse tan of whatever the ratio is. So the inverse tan of the ratio, which was 1.2. So let's figure out what the angle was that gave us 1.2. So on your calculators, second function tan of 1.2. That angle to the nearest degree is 50 degrees. Okay, so that angle is 50 degrees. And then I would say angle x is equal to 50 degrees, is how we would write this. How I could check is the following. I know that this is now 50, so now I'm going to type in the tan of 50 degrees, and I should get 1.2 as the ratio. So my calculator, the tan of 50 degrees is 1.2. Okay, so you know how to find ratios now, and you know how to go backwards and find angles, because we're going to need to be able to do this tomorrow. Okay, for all of these questions here, what did they give me? Are these guys ratios or angles? They are ratios. So for all of these, we are going backwards. And what I want you to write for all of them is, so underneath each one, I want you to write the sine, the inverse sine of the ratio is equal to, and then that will be the angle. And they want it, it says to the nearest degree. So this first question, I'm going to clear this. Second function sine of 0.3584. And I get to the nearest degree, that would be 21 degrees. And then they have here angle A is equal to 21 degrees, and I would box that in. So I want you guys to do B, C, and D. I want you to write it correctly because I will always give a mark for that on a test. So writing it correctly. So for example, B would be the inverse cos of the ratio is equal to the angle. So whenever we go backwards, we're finding angles. So get what this angle is to the nearest degree, what C is, and what D is. And then I will give you, that's the lesson, and I will give you your homework, and we'll set up 2 as a class. And then tomorrow we'll really start solving the triangles. No, because this one's to the nearest degree. So it would be 57. Exactly. Okay, Jack, what's the answer for B? 57 degrees. Next one, tan of P, angle P. Owen, what would angle P be? 73 is correct. And last one, Juan, what is angle C? I'm not getting 60. Is that what you got, 60? Let me double check. Are you guys getting, I'm getting 30. Let's check. So second function sine of 1 divided by 2, 30. So double check that one, why 60 came up for yours. Oh, 60 would be if you typed in cos. Okay, so this is 60 degrees. What's that? Oh, it's 30, sorry. 30 degrees. Okay, let's circle your homework. So question number 1, I want you to do the first 6. So we don't have to do anything else in this lesson. So question number 1, get the first 6 done. Question 2 to 4, so circle 2 to 4. And then I've got 11 and 14 starred. So let's see why 11 and 14 are starred. Okay, so we're going to do 11 together, and then we will do 14 together. Actually, let's just start with 14. This is a calculator question. So Piper, this sort of answers your question. If you don't close the bracket, you'd get this one wrong. Okay, so this is just straight punch this in on your calculator. So what we always have to do is type in the numerator first, and you hit enter. Then we're going to divide it by the denominator, hit enter. So cos of 30 plus the sine of 30 would be cos of 30 degrees plus the sine of 30 degrees. Give me that divided by the tan of 30 degrees. And you should get as an answer, what did they say they wanted it to? The nearest 10th. So what would my answer be? 2.4. Are you guys all getting this? Okay. 2.4 is the answer. 2.4. Okay. Next question, let's look at that number 11. Consider the right triangle shown Referring to triangle ABC, write the rational number which represents the indicated trig ratios. So we are just going back to trig ratios. So let's start with all of these A's. So starting with the A's, the A gets the eyeballs, and that would be opposite, hypotenuse, and adjacent. I'm going to write SOHCAHTOA. And the sine of angle A, Alexa, would be what? Yes, opposite over hypotenuse, which is 4 over 5. The cos of angle A, Avery, would be what? Yes, that would be 3 over 5. And the tan of angle A would be, Kai, what would be the tan of angle A? Sorry? 4 over 3. Tan is TOA, yeah, 4 over 3. Now, you guys, I want to show you something really interesting. If I said find out what angle A is, we could go backwards using sine, using cosine, or using tangent. Can you quickly type these into your calculator? So let's figure out what angle A is going backwards. This is what we're going to be doing tomorrow, and we're going to be filling in our triangles. So if we started with sine, I'd type in second function sine of 4 over 5. So this is just to sort of give you a preview of tomorrow, and I get 53 degrees. So I'm getting 53 degrees for angle A. Now let's check if we do the cos of that ratio. So let's see what we get when we type the second function cos of 3 over 5. What do you guys notice? It's the exact same number because angle A is not changing, right? Angle A is 53 degrees. Let's type in the tan. Let's find out the angle using tan. So second function tan of 4 over 3 this time. Same answer. So when I say calculate angle A, and you have 3 to choose from, it doesn't matter what you choose, you're going to get the same answer. A is 53 degrees, right? So whether we use the sine ratio, the cosine ratio, or the tan ratio, as long as you have your ratios correct, you're going to get 53 degrees for each one of these. The same is going to go for B. When you guys relabel your triangle according to angle B, so here's angle B, opposite, hypotenuse, and adjacent. Sine of angle B is O over H, which would be 3 over 5. And let's calculate what angle B is. Angle B would be the inverse of that, so the inverse sine of 3 over 5. Angle B is going to be 37 degrees. So if I put that in, yes, Piper. Okay, so what would we do for B and C? Okay, so let's finish off this question then. So I just got to put degrees here. Okay, Piper, what did you say the cos of angle B was? What's the ratio for cos of angle B? 4 over 5 is correct. And Cohen, what is the tan of angle B? Yes. Okay, so let's see. Which pairs of trig ratios have the exact same values? Do you see what it would be? Sine of A is equal to which one? 4 over 5. So this trig ratio, you guys, sine of A, how they want you to answer this is this. Sine of A is equal to cos of B. Yep, these two are equal. Is there another one that's equal? What is it? Cos of A is equal to which one? Sine of B. Okay, Last question. How do the values of tan A and tan B relate to each other? So look at tan A, it's 4 over 3. This guy is 3 over 4. They are reciprocals, is how they relate. They are reciprocals. So this B was just asking what ratios are the same. And C was asking how do these fractions relate? They're reciprocals of one another. And that's the lesson.